3.6 The chain rule. In this next section, we're going to learn how to take the derivative of composite functions. In previous videos and examples, we've seen how when we have a composite function, we distribute out or simplify in order to create a function that is no longer composite so we can take the derivative. The chain rule makes it faster and easier to take derivatives of more complex functions. So if we have f of x is equal to sine of x and g of x is equal to x squared minus 4, then f of g of x is equal to sine of x squared minus 4. And that's just writing my function as a composite function. So now if I want to take the derivative, I can't use the product rule because we're not multiplying. I can't use the quotient rule because we're not dividing. And I can't use the power rule because there is no power. So we need to use the chain rule. So in example 1, we have y is equal to 6x minus 10, which I can rewrite as 2 times 3x minus 5. And the reason I'm doing this is to show you how to use the chain rule with a composite function. And so what I'm going to do is I'm going to write y is equal to 2 times u. And so what I'm doing is I'm substituting the 3x minus 5 for u. So I'm letting u equal to 3x minus 5. And so now I'm going to get two functions. I get y is equal to 2u, and I get u is equal to 3x minus 5. And now what I'm going to do is I'm going to take the derivative of both. Now notice that in the very beginning of my equations, I have y equals and then something with an x. So my goal is to get dy dx. Now if I take the derivative of the first one, I have to take the derivative with respect to u. And if I take the derivative of the second one, I have to take the derivative with respect to x. So I'm going to get dy du is equal to, and the derivative of 2u is just 2. And then if I take the derivative of my other one, I get du dx is equal to, and the derivative of 3x minus 5 is just 3. And so dy dx is equal to dy du times du dx. So notice that the variables cancel off. And so if I rewrite this as dy dx, I get dy du was 2 and du dx was 3. So 2 times 3 is 6. I also want to point out what would happen if we took the derivative right away. So I have y is equal to 6x minus 10. So if I take the derivative with respect to x right away, I get the derivative of 6x minus 10 is just 6. So I end up with the same result. The reason I wanted to show you with an easy function was because I wanted to show you with a derivative that you could take a different way to show you get the same result. For this particular problem, I wouldn't have done the chain rule, I would have just used the power rule. Alright, moving on to part B. In part B, this is something that you will need the chain rule for. So the first thing we need to do is identify our outside and our inside functions. Our outside function is cosine, so I'm going to call this y, and our inside function is 2x plus 1, so I'm going to call that u. So I get y is equal to cosine of u, and I get u is equal to 2x plus 1. So now what I have to do is take the derivative of both. So I take the derivative with respect to u for my first function. So I get dy du is equal to negative sine of u. And for my second function, I take the derivative with respect to x, and I get du dx is equal to 2. And so I have dy dx is equal to dy du times du dx. And so this is equal to negative sine of u times 2. So I get negative 2 sine of u. Now the only problem with this right now is that it's in terms of u and I need it in terms of x. So I get dy dx is equal to negative 2 sine of 2x plus 1 because u was equal to 2x plus 1. So now on your own, I want you to try y is equal to sine of x to the fourth minus 1 by using the chain rule. Alright, let's give it a try. So I'm going to identify my outside function as y and my inside function as u. So I get y is equal to sine of u, and I get u is equal to x to the fourth minus 1. So I take the derivative with respect to u, and I get dy du is equal to cosine of u, and then I take the derivative with respect to x, and I get du dx is equal to 4x cubed. And so from here, all I have to do is finish it off by writing it out. So I get dy dx is equal to dy du times du dx. And dy du was cosine of u, and du dx was 4x cubed. So I get dy dx is equal to 4x cubed times cosine of x to the fourth minus 1.